I'm going to stop this video. I hope you all enjoyed looking at the video. My name is Dave Taylor. I'm the product manager for the Xcelon line, and Xcelon is one of their newer products. I will be recording this video. I will be sending everybody a link who has attended to review the video or to view it again. And if you'd like to send some people that link also, feel free to do that. We have Ryan Hoger, who's our Director of Training, on the line with us. He's also one of the staff here. And we also have a couple of the experts from Xcelon in attendance today. And if there's any really tough questions, I will kind of refer it to them. I'll read the question to them, and they can answer it for us. At the end of the session, I'll also be announcing some meetings where the experts will be in town in person, and later on this month, where you can attend and ask them questions to your heart's content. So that is in one of the slides at the end, so stay tuned for that, please. And with that, we'll start. If I pause them a little bit, I'm just kind of looking at some questions. So if you hear a little pause there, I will just be reviewing the questions. If we can't answer you right away, we'll be sure and get you an answer to your question. All right. Xcelon is Xcelon's new makeup air unit. We're going to talk a little bit about the state of the industry right now as far as what's out there for efficiencies, some of the advantages and disadvantages, and limiting factors. Right now, the clamshell heat exchanger is probably the most commonly used heat exchanger out there. It is in the Xcelon product line. Each clamshell section is about 400,000 BTUs, and that 400,000 BTU figure is pretty consistent across all the different manufacturers out there. If you put two of them together, you can see what happens is you have 1700 degrees at the inlet and about 400 degrees at the outlet. Being non-condensing, 400 degrees is pretty typical across the industry. But unfortunately, what happens is that when you have two in series, you start out with 80% efficient on the first one, but you don't end up with 80% efficient on the second one. And this is fine per ANSI standard 83.8. It only requires you to test one furnace at a time. It doesn't require you to test two furnaces in sequence. So you can see that the second furnace is losing 5 to 6% efficiency, mostly because of the higher entering air temperatures on the secondary heat exchanger. If you can imagine 3 heat exchangers, or 1.2 million, you're down around 70% efficiency. One of the other things too is you have air stratification with the much higher inlet air temperature and the much lower leaving air temperature. You can see you could have a 10 to 15 degree delta T from the inlet to the outlet, or the lower to the upper. And if you can imagine a horizontal feed to your building, those first few rooms, if you do a takeoff from the bottom, are going to get heated very quickly. And the rooms at the end of the line are going to get the colder air. So that could lead to a lot of comfort complaints from the occupants, depending on where the thermostat is and how fast the rooms heat up. Now, tubular heat exchangers are a little bit more efficient. You can see that there's a 350 degree air leaving the combustion chamber, and this allows them to 82–83%. And there's also improved reliability because of the one-piece construction instead of two, which is like on the clamshell. So tubular is a little bit better, and Xcelon does have a tubular line too in some of their unit heaters. Moving on to the 90% group, what you have to do is either keep the air in the combustion chamber longer or increase the area, or do both. That gives you the 93% or the 91% efficiency. These are some of the competitors out there. You can see the competitor on the left is a tubular primary, fin and tube secondary, and of course 150 degree air temperature, meaning that it's condensing. And the one on the right is a clamshell primary and fin and tube on the secondary. But these are only in smaller capacities. These are maybe to 400 to 450 MBH. When you try to scale, you have different issues, which we'll talk about next. You can see if you're going to try to scale in series, you have the same problem as before. The efficiency goes down. So if you started at 91% efficient, second heat exchanger is only 86, and if you had 3 in a row or more, it goes down to 80% on the second one, or certainly the third one, and even more if you have 4 in a row. And this is at design conditions. If you have it at less than design conditions, it could be even worse. So, you could put them in parallel, but the problem is if you put them in parallel, you're going to have either a very tall or very, very wide heat exchanger, which isn't too practical. Now, some other problems is the air stratification. At full load, it will be okay. But if you get down to around 40%, one of the heat exchangers is going to be kicking off. If it's the top one, in this particular case, you could have cold air at a part load condition, 35, 40 degrees coming out the top heat exchanger, and 70 degrees if it's a 100% makeup air unit coming out the bottom. This is going to really provide some comfort issues, unless you mix it well. But a lot of times I don't see it in a blow-through configuration like this. I don't see mixers or blenders downstream because they contribute too much to the static pressure loss. So as you scale up, an air-to-air heat exchanger causes many, many problems. A couple of the other problems is the staging. Single stage is limited that it can only fire at 100%. In order to maintain a temperature set point, the unit has to rapidly cycle the burners. Each time a burner lights, it has what is called cycle loss, which lowers its efficiency when it first fires. This is due to the amount of gas that's released prior to ignition to ensure that the burner lights. With the modulating gas control, since the surface area is constant, the efficiency of the unit will improve as the firing rate is reduced. Below 130 degrees, the flue gas condenses into a corrosive liquid. This means the minimum fire rate must be set so the flue gas will always be above 130 degrees before it enters the secondary heat exchanger. That way it ensures no corrosion and premature failure of the primary. The other option is to build a primary out of stainless steel, which would drastically increase the cost and the weight of the unit. The other problem is the air-to-air gas ratio, which is usually maintained at 1:1. However, as you turn down the gas in a typical system, the air remains constant. This can lead to an increase in carbon monoxide production above the legal 400 parts per million limit. In order to eliminate this, the minimum turn down must be either set above the point where this occurs, or use a 2-speed or variable speed power venter to get past the 1:1 ratio. Combined, these determine the minimum fire rate for the unit. So, problems with larger capacity units at 90% are very, very real. Okay, introducing the Xcelon unit to take care of all these problems. The Xcelon unit is an evolutionary unit, not a revolutionary unit. It uses components that have been around, that are tested and tried and true. Not revolutionary, new design components that could take a couple years to work their way out. Instead of a clamshell or tubular heat exchanger, Xcelon uses a high-efficiency boiler and hot water coil. It has a 30% propylene glycol loop as the intermediate heat transfer medium. There's no connections of water to the unit. This is all internal. The only unit connections are ductwork, gas, and electricity. Now, why hydronic? Well, as we all know, water holds more energy than air, so it's a better medium to transfer heat. You can transfer the same amount of heat in a much smaller surface area than air to air. Plus, user comfort is not just for the occupants. In factories or processes that require a specific temperature to be maintained, Xcelon can maintain a specific constant air discharge temperature to within plus or minus 0.5 degrees. Let me repeat that. Xcelon can maintain a constant discharge air temperature to plus or minus 0.5 degrees. Again, scaling with the competition units, they can't hold that. At low CFMs in a typical system, as you turn down the CFM, the delta T at the supplier increases. With a modulating gas control, you can turn down the gas valve, but once you hit the minimum firing rate, you risk cracking the heat exchanger or tripping the high limit if you continue lowering the CFM. Depending on the controller used for the unit, the minimum CFM is either defined by the maximum discharge temperature at full fire, or in a more complex controller, the maximum discharge air temperature at minimum fire. The limiting factor on Xcelon is the minimum speed of the fan and the VFD. And since the agencies classified the unit as both a boiler and air handler, it is eligible for boiler and VFD rebates, and it could contribute to some lead points. We'll talk about that a little bit later on. Alright, this is how the unit works. The boiler side is on the right here. Here's the fan, here's the heating coil, and here's an optional cooling coil, filter section, and of course inlet section. The GPM is constant, but the glycol loop temperature varies on the discharge set point in the outside air. While the flue gas still has a large delta T, the delta T of the propylene glycol loop is only 50 degrees. This is what allows the unit to maintain that discharge temperature of plus or minus 0.5 degrees. So this high temperature difference allows the boilers to maintain their efficiency. All we do is change this delta T here to satisfy the discharge air temperature. Alright, this is a little diagram, and you can see here's the heating coil. Now on the heating coil it does maintain a 1 degree plus or minus temperature difference, but in the fan section it does a lot of mixing, so in the discharge you have a plus or minus 0.5 degree temperature difference. And what does this do for you? Well, it helps you reduce the risk of inaccurate sensor reading with the duct sensors. And also, since you reduced that large delta T, you've reduced customer complaints. Now this is a unit that was installed in 2012. You can see that the data was taken on February 2012, and it's in Westfield, Massachusetts at a municipal airport. And you can see the top graph is 0.5 degrees set point difference, and this is over a cold day. Now, a little bit about the performance. On average, it's about 93%. But if you have discharge temperature set at 70 degrees, that efficiency goes to 98%. And I might add that 98%, there's no electrical savings involved in that 98%. We'll talk a little bit more about the electrical savings. The gas valve is fully modulating. There's two boilers, so you have a 5-to-1 turn-down ratio on both, or a 10-to-1. And I'd like to make sure that you realize that the 35% glycol mixture protects the unit down to minus 30. Okay. Got a question here. Can this unit be connected to a CHP system? Can you give me a little bit more idea? CHP, can you explain what that acronym is? And we'll try to get back to you.
It's a combined heat and power system.
Thank you, Ryan. Combined.
Not sure what they'd be doing in terms of connecting it, though. It doesn't make. I'm not sure what they're trying to do. Combined heat and power means you're generating electricity and using the waste heat to heat the buildings. So I would say it's not applicable to an air handler.
Okay. If you have any other ideas, if you can type them in the question box, we can get back to you. And any questions we can't answer, we'll get back to you in some form or another. Alright, these are some more data gathered on some different set points. And you can see at 70 degrees temperature, discharge temperature, which is common for most makeup air units, 100% makeup air units, you can see at different outdoor air temperatures it maintains a 97-98% efficiency. At 100 degree outdoor air temperature, it's still above 90%. It's 92 to 94. At a 120, it goes a little bit below the 90% range. So if you're using it for space heating too, you're still a lot higher than this typical power vented unit. And that's over the whole range. Remember, as you go down, or as you go up in outdoor air temperature, the efficiency could go down. And as you put different units together above 400, the efficiency drops and drops and drops. But this is at 88, 89 to 98% over the entire operating range. Alright, we talked a little bit about variable speed power venter wanting to maintain the 1-to-1 gas ratio. It allows the unit to maintain that 1-to-1 gas ratio, and it improves the efficiency at part loads. With a constant speed power venter motor, the fuel ratio has constant air input and a decrease in gas input at part loads. This leads to an increase in carbon dioxide and a decreased efficiency at part loads. Alright, a little bit about the electrical efficiency. As we talked about, most people use a air-to-air clamshell type heat exchanger, which could have 1+ inches of pressure drop. If you put 3 of these together in a 1.2 million, you could have 3+ inches of pressure drop, internal pressure drop, just in the system. What Xcelon does, it uses a hot water coil. So regardless of the BTU input and CFM selected, the hot water coil stays at 0.5 inches of static. So the Xcelon unit, in initial release, which has already been released, is 800,000 MBH and 1200 MBH. And that has a varying range of CFMs. Over that varying range of CFMs in each of those sizes, you maintain 1/2 inch of static loss. And also, let's not forget that that can reduce your motor horsepower size, and also electrical savings. It also reduces your disconnects, everything else associated with lower motor horsepower sizes. Now the unit does come, or you can order as an option, a DX or chilled water coil. And what happens in the cooling mode, of course the air goes through the chilled water coil. In the heating mode, there's a bypass damper that opens up on top. So it bypasses the air into the heating coil. When that happens, there's less static pressure and the VFD can ramp the fan down. And that results in reduced amp draw and lower electrical operating costs. So right now it's initial release. This is a split system. This is only a DX or chilled water coil. We're going to talk a little bit about future releases on the next slide. They will have, excuse me, in the second quarter of 2015, integral cooling. So a compressor and a condenser in phase 2. So what that's going to help you do is if you want to dehumidify the supply air, let's say from 95 to 76, it needs to be first cooled to around 49 to remove the moisture. Then you've got to heat it up to about 58 before leaving the unit. Normally this would require an additional 1 to 2 row hot gas reheat coil. The drawback is that an additional coil increases the internal static pressure drop and therefore the brake horsepower, the amp draw, and everything else. What Xcelon does is that they reuse the hot water coil to minimize the internal static pressure drop. And as an added benefit, by using the heat exchanger to transfer heat from the saturated liquid refrigerant to the glycol loop, we subcool the liquid refrigerant, which increases the cooling SEER. Now when this is introduced, they'll have this up to 40 pounds. Let's talk a little bit about the energy recovery. This is the boiler compartment here with the VFDs, the pumps, everything else. This is open to atmospheric pressure. Here, of course, is the fan motor. Heat recovery recovers the heat from all these heat generating devices here just by using natural progression from the higher pressure areas down to the lower pressure areas. Of course, there's a negative pressure in front of the coil. So the air just translates right down here and it gets reclaimed, all that heat from the pump, the VFDs, the boiler, and that recovered waste heat increases the efficiency by 1%. Now, it comes standard with a 1-inch insulation or an R6.3. You can get it as an option with 2 inches of insulation, an R value of 11, to make sure no heat is lost. Some additional features. All the operating points are on the right side of the fan curve here, and all the units are going to be made to operate at a maximum of 3 inches of true external static pressure. Some more of the options are spring isolation is standard. Of course, this reduces the fan noise and operating transmission since most of these units are up on the roof. A little bit about the piping. In a closed glycol loop system, there is no water connections required to the unit or through the roof. Now you will need to maintain the glycol water mix per the glycol manufacturer's recommendations. In the case of the glycol supplied with the unit, the manufacturer recommends the glycol can be changed when it's below pH of 7. There's about 13 to 14 gallons of water/glycol in the system, so when it comes time to change or charge the glycol loop, all you need is 2 5-gallon buckets of water and 1 5-gallon bucket of propylene glycol. You can also see in the unit the air separator, the expansion tanks, drain, fill, and purge valves, flexible hose to allow for movement during the shipping without it breaking the pipes, pumps, pressure relief valves, and the boiler high vent and pressure gauges. I'm just checking questions here. Somebody asked what's the distance between the heating and cooling coil, and I remember from the unit that was brought around back in May, it was probably about 8 inches. But if the Sterling reps can kind of answer in the question box if I'm a little bit off, please do so. Alright, while they're answering me, I'm going to just move on to the next slide here. Always the first question is, what happens to the condensate? Well, The condensate trap has a weep hole that allows the water to drain out of the trap in less than 60 seconds if there's a power failure. Obviously, you wouldn't want the condensate freezing if there's a power failure. There's a condensate neutralizer. That's this cylinder down here. And the inlet is on the top of the neutralizer and the outlet is on the bottom. In the event of a power failure, the majority of the condensate will drain out. The remaining condensate has plenty of room to expand, so freezing will not break the neutralizer. Once the unit regains power, that 90-degree condensate will quickly melt any frozen condensate in the neutralizer. Now, this condensate neutralizer is an option. Not everybody, not every code municipality does require it. There's also a bypass line. You can see the bypass line right here if the condensate neutralizer does get clogged. And the condensate can either be piped out the bottom of the unit or it can go outside the unit itself. This one is showing that the unit is going outside the unit. Now if it goes outside the unit, there would need to be heat traced by others. But one of the other options is also a convenience outlet, so you can plug in any kind of heat trace. And I've been told it's about 14 inches. The cooling coil is about 14 inches from the heating coil. Thank you for that. All right, a little bit about the controls. When the system first is enabled, calls for heat, the burners fire. They bring the glycol mixture up to an air temperature set point. Once the glycol is up to temperature, the VFD is then slowly ramped up to speed as the control maintains the discharge air temperature. Once startup is complete, the discharge air temperature and pressure is maintained. You have an optional setting if the unit is unable to maintain the discharge air temperature. The blower speed can be reduced to allow the discharge air temperature to be maintained. Remember, they change the temperature of the glycol mix to the outside air temperature and the supply air discharge set point. The controller comes in different configurations. Modbus is standard, but you can get options for BACnet and LonWorks. A little bit about the controls on the boiler. The proportional integral derivative. The boiler is controlled by this proportional integral derivative. By looking at the rate of change, it keeps the boiler from making sudden and unnecessary changes. It also helps to prevent the system from overheating the discharge air temperature. When the propylene glycol mix is within this heat band, the boiler modulates to maintain the discharge air temperature. In the event of temperature rises above the heat band, the boiler will stage burners off until the discharge air temperature has fallen below the heat band minimum. By limiting the maximum fire of each of the burners to 50% until all the burners are on, it also helps to maximize efficiency and ensure all boilers are condensing. At part load, the boiler efficiency improves due to the larger surface area compared to the BTU input, allowing for more heat transfer. In order to ensure the maximum life expectancy, the runtime of each burner is monitored and the primary burner is rotated so that the burner number 1 is always the one with the least amount of runtime. A little bit about the safeties. There's a high limit trip at 205 degrees with a plus or minus 7 degree temperature difference. A low water cutoff using a pressure switch to ensure there's sufficient charge in the glycol loop. An ignition fault, it locks out the unit after failing to alight the unit on the first attempt. And there's software operating limits to reduce the fire rate of the boilers and maintain the minimum glycol temperature. On the air side, the VFD temperature status prevents the VFD from running in temperatures below 25 degrees. When the temperature is below 20, The controller enables a small electric heater within the VFD enclosure to bring the box temperature to an acceptable level. The electric heater is about 150 watts, and for larger horsepower motors and VFDs, the heater may be 300 watts. Damper proving switches also give the damper 30 seconds from the time the dampers are told to open before shutting the unit down, the boiler and the VFD after the initial failure. A little bit about service. The unit was designed with ease of service in mind. There's isolation valves on all the boilers, and the boiler is on a track for easy pull-out to repair the unit, whether it's on the roof or inside. Service lights are standard on all units, so no having flashlights and looking for a magnetic side to put your flashlight on to light up, look at different things when you're repairing things. Optional convenient outlets are available. Again, you could use that for the heat trace. You have an optional clogged filter switch, and the external control terminal strip is on the outside of the unit for ease of thermostat wiring. The unit has a sloped top, like you can see here, for drainage of snow and water. And this sloped top is not the inside unit part. The inside is also down here, so you're maintaining the full insulation value. A little bit about performance. The whole line has a maximum discharge of 140 degrees and a maximum temperature rise of 100 degrees. It will go from 4,500 CFM to 15,000 CFM, and all those sizes will be available to handle 3 inches of external static, and 800 to 1,600 MVH. The initial offering, which is already being offered, is 4,500 CFM to 10,000 CFM, and 800 and 1,200 MVH. You can check questions here. Okay, no more questions. All right. A little bit about rebates. Nicor rebates is more a tiered rebate. The X1, the Xcelon 1, at the 800 MBH is $2,500. From 12 to 1,600, it's $5,000. Peoples and North Shore is a little different. They're $3 per MBH, which translates into $2,400 for the 800, $36 for the 1200, and $4,800 for the 1600. ComEd has VFD rebates at $60 per horsepower, which translates into about $600 to $900 per unit, depending on the motor horsepower and the CFM and static pressure. And the Department of Commerce and Economic Opportunity has a whopping $14 per 1,000 BTUs. That's not a misprint. $14 per 1,000 BTUs. And the Department of Commerce and Economic Opportunity are more state and government buildings. Firehouses, town halls, anything that's government or municipal related. So right now in the first offering at that 1,200 MBH, you can get a rebate of $16,800. Now, that factors into the I forgot lead points. Xcelon could contribute to overall building performance to help accrue lead points. We can't tell you how many lead points it can accrue because each situation is different. But it could fit in under these classifications: the optimized energy performance, the PBT source reduction, enhanced indoor air quality, thermal comfort, or exceptional or innovative performance. So each building is individual, but it can help accumulate or accrue lead points. A little bit about payback. Payback is an important option when you present this to an owner. We did a few studies here in Chicago, and these studies were using a 90% gas rate, or 90 cent per therm gas rate, 10 cent per kWh for electrical rate. It included the Nicor utility rebates, and gas and fan savings energy were included in this. But for the 1200 MBH unit, our paybacks were 3.4 years or 4.6 years, depending on the operation cycle, 24/7 or 12/7. The 800 MBH units, the payback was 5.1 or 6.4 years, depending on the operation cycle. That's a 21 to 25% operating cost savings over a standard power vented unit. And those paybacks fit in very well with most owners who are installing a makeup air unit and that are going to be using this for a long period of time. We have an application here. They've had many units. Sterling has had many units out in the field for 2 years. Right here in Chicago, at Toronto Bakery was one of them, and there it's in Berwyn, Illinois. It was installed in October of 2012, and it's had no issues in 2 years. And according to Broche Mechanical, it is very simple to install. I have been up to see this installation myself, and it's very clean, and this is what it looks like. Now I want to show you, I want you to notice that the existing curb, they took off the Sterling makeup air unit, and they had to do nothing with the existing opening. There was a curb adapter that had to be done, and had to be made, but it fits right over the existing opening. So with higher efficient, higher capacity units in the 800 to 1.2 million, you don't have to extend or widen the unit and have a huge unit on there. You can use the existing roof penetrations. This one had an outside. This one didn't have a condensate neutralizer, but you can see the condensate line is going to the outside. Here's the condensate line, and the condensate line was probably 35 feet. Now it did have heat trace on it, but over 2 years, and the last winter, of course you all obviously know, was one of the most brutal winters we've ever had, that had no problems. Oh, and I forgot to mention the rebates in northwestern Indiana. NIPSCO does have rebates too for high efficiency boilers. Now, as a follow-up, you can talk to the experts. Sterling and their field of experts are going to be in Chicago on the 23rd and 24th. On September 23rd, there's going to be a meeting downtown from 11 a.m. to 2 p.m. It's going to be at the Renaissance Hotel on Wacker Drive. And if you don't have your invitation, speak to your TEC representative, or you can contact me or anybody from TEC. Just call up the main number at 708-418-0900 and I'll send it to you. But there are 2 PDH credits involved. I'm going to be doing a more basic talk on the basics of makeup air, along with the Sterling representatives talking on their unit. Lunch will be served, and to help us out, if you don't get the invitation from your TECTM, go to tecmungo.com/training. Again, that's tecmungo.com/training, and you can sign up there. Please do that so we can have the appropriate food and beverages. They'll also be here the next day. They'll be here for demos on September 24th in the suburbs or downtown. We can come see you, do individual demonstrations if you can't make it to that meeting. All we ask you to do is to see your TECTM to reserve a time. But in each one of those, space is limited. And like I said, factory personnel will be in attendance. Let me just check for questions one more time. Okay, we have a bunch of questions here. Okay, we have some people just a little skeptical about the efficiencies. Let's see. let's see, the question is, how is heating water with gas and then storing it until the heat is needed from the water source more efficient than just using the above indirect fired system? Well, as one of the slides showed, transferring heat is more efficient with water. So you're not going through another medium there. So water per unit can hold more heat than air. That's how you're getting the efficiency above 90% or the full range. Let's see. What is the expected equipment?
Dave,
Yes,
can I add to that?
Yes.
Because if you're transferring heat to water and then water to air, it's one more transfer, not one less transfer. The reason that it's more efficient using the boilers is that we're able to run them in a condensing mode, which reduces the flue gas temperature, right? So the heat that's being burnt either has to go out the flue or has to go into the airstream. So if our flue gas temperature is lower than a traditional heat exchanger's exhaust temperature, that means our heat's going into our building and not out of our exhaust pipe. That's how we're able to get a higher efficiency here.
At all load conditions too. What is the expected equipment life? Well, basically it's just the boiler and the fan, and the boiler's expected life could be up to 20 years. So it's no different than like we would think with a heat exchanger that could crack, or a tubular heat exchanger that could also wear out on the first few bend. That could be an issue. These are just boilers and fans. And
we use those same boiler heat exchangers in other boilers that we use at TEC. They're Janoni heat exchangers, so we're pretty familiar with them, and it's not uncommon to get 20 plus years out of them. The boiler will probably outlast the sheet metal cabinet in the long run.
One question is, do the units have a seismic or wind rating? That one I'm not sure of, so if the Sterling guys could answer that. Some of these questions are pretty, one is about a weight difference between the standard makeup air and the high efficiency unit. There's one about a cost estimate. We don't talk about costs on webinars. I would advise you to see your TECTM and ask them. And there's a question about forethought in a loss of glycol in a catastrophic failure. Let's see, would the blower immediately shut down, thus preventing spraying into the ductwork? I'm not sure what you mean by a catastrophic failure. You mean like a power failure? Or maybe a meteor hitting this? Or I'm not quite sure what you're talking about when a catastrophic failure.
I think he's basically asking if there's a freestanding unit to shut the blower down in the event of there being an issue like that, where you're not heating the water. So, for example, if the boiler failed and I happen to leak some glycol out and I had a lower percentage, what additional controls are there? What belts and suspenders do you have is what he's asking.
Yeah, it's just, they said, no simplified phrase. Let's see. There's a moisture sensor in the floor of the boiler section. So if the boiler did leak, for example, there's a moisture sensor that would shut down the boiler. I'm just looking in some other questions here. Yeah, some of these other questions are more detailed, like the weight difference. I don't have that off the top of my head. I would probably suggest that your TECTM can get you information. Or you can either come to the show on September 23rd or call your TECTM and have us out individually on a one-on-one basis. Alright. I appreciate everybody's time. I look forward to seeing you on the 23rd or the 24th. Again, if you want to go on the 23rd, please sign up at tecmungo.com/training. And I look forward to meeting you individually for this new exciting product that Sterling is offering. Thank you very much. And like I said, the webinar will be, the link will be sent to everybody so you can pass that on. Thank you very much.